Hello students, welcome to the lecture on Introduction to Computer. And after the lecture we will be able to learn the following objectives. Discuss the strengths of computers, explain the limitations of computers, discuss the fundamental uses of computers, explain the developments of computers, describe the types of computers, define the generations of computers. Let's start with a brief introduction to the Introduction to Computer. The word computer comes from the word compute, which means to calculate. Hence, people usually a computer to be a calculating device that can perform arithmetic operations at high speed. In fact, the original objective for inventing a computer was to create a fast calculating machine. However, more than 80% of work done by computers today is of non-mathematical or non-numerical nature. Hence, to define computer merely as a calculating device is to ignore over 80% of its functions. More accurately, we can define a computer as a device that operates upon data. Data can be anything like biodata. Hence, computer is used for shortlisting candidates for recruiting, marks obtained by students when used for preparing results, details, name, age, sex, and so on, of passengers when used for or railway reservations, or a number of different parameters when used for solving scientific problems, and so on. Let's now discuss about the strength of computer. Increasing popularity of computers has proved that it is a very powerful and useful tool. The characteristics of strength of computers. Automatic. An automatic machine works by itself without human intervention. Computers are automatic machines because once started on a job, they carry out the job normally without any human assistance until it is finished. However, computers being machines cannot start themselves and cannot go out and find their own problems and solutions. Speed. A computer is a very fast device. It can perform in a few seconds the amount of work that a human being can do in an entire year, if he or she worked day and night and did nothing else. In other words, a computer can do in a few minutes what would take a man his entire lifetime. While talking about the speed of a computer, we do not talk in terms of seconds or even milliseconds, 10 minus 3, but in terms of microseconds, 10 minus 6, and nanoseconds, 10 minus 9, and even picoseconds, 10 to 12. A powerful computer is capable of performing several billion 109 simple arithmetic operations per second. Versatility. Versatility is one of the most wonderful things about a computer. One moment it is preparing results of an examination, next moment it is busy preparing electricity bills, and in between, it may be helping an office secretary to trace an important letter in seconds. No intelligence quotient, IQ. A computer is not a magical device. It possesses no intelligence of its own. Its IQ is zero, at least until today. It has to be told what to do and in what sequence. Hence, only users determine what task a computer will perform. A computer cannot take its own decisions in this regard. The limitations of computer. No self-intelligence. Today, a computer is able to do a work which is impossible for man. Computers are used to do risky and dangerous work and where sharp actually is needed. But it does not have any intelligence of its own. It works according to the instruction only. No decision-making power. Computer cannot take any decision of its own. It does only those tasks which are already instructed to it. No learning power. Computer has no learning power. Once one gives instructions to a computer how to perform a task, the very task cannot be performed if one does not give it any instructions for the next time. Let us now talk about the fundamental uses of computers. With technology continuously evolving and intertwining into everyday life, people are using computers for more and more simple tasks. Communication. Many people use their computers to keep in touch with friends and family using instant messenger programs as well as email. A growing communication tool is social networking, with sites like Facebook and Twitter becoming incredibly popular. Games. The PCs have long served as recreational devices with hundreds of games available each year. Gaming on a PC can be an expensive hobby, with video cards ranging in price from $60 to more than $20,000. Entertainment. Computer comes with a CD or a DVD disc drive, which allows one to use the computer as a CD player or a DVD player. Some computers are also capable with the proper hardware of viewing and recording television onto the machine's hard drives. Work. Office buildings use computers to keep track of everything from pay wages to hours logged. Retail stores using computers also as cash registers, and industries such as construction and architecture use computers to help design buildings.
Hello everyone. Today we are going to discuss about the uses of computers. It can be used in home. It can be used at home for education, entertainment, using internet, email. And computers can be used in the bank for calculations, accounting, etc. Computers can be used in factories for design and automation, designing the product, and the process can be automatically run. It can be used in the schools for education. The learning activity can be done with the help of education. Music directors can use computer for composing their music and editing it. Offices, it can be used for typing text and data, store it, print it. If it is needed, it can be sent through email, which is a fast, economic and convenient way to send text data. Doctors can use computers for finding the diseases and prescribing the treatment. Artists can be used the computer for drawing and painting. Movie directors can use computer for making movies and editing it. Engineers are using computers for designing. In the laboratories, it can be used for researches and experiments. These are all the general uses of computers. It can be used at home, bank, factories, schools, by the music directors, in the offices, doctors, artists, directors, engineers, and it can be used in laboratories for the research purposes. The given examples are only a few out of many. The summary: home, bank, factories, schools, music directors, offices, doctors, artists, directors, engineers, and lab. Home for education and entertainment, bank for calculations, factories, design and automation, schools, education, music directors, compose music, offices, type data, doctors, diseases, finding diseases, artists, drawing and painting, etc. Hope you enjoyed this video. Thank you.
We shall now discuss the development of computers. Necessity is the mother of invention. The saying holds true for computers too. Computers were invented because of man's search for fast and accurate calculating devices. Basic Pascal invented the first mechanical adding machine in 1642. Later in the year 1671, keyboard machines originated states around 1880 and we use them even today. The Mark I computer 1937 to 44. Also known as automatic sequence controlled calculator, this was the first fully automatic calculating machine that was designed by Howard A. Aiken of Harvard University in collaboration with IBM International Business Machines Corporation. It was an electromechanical device which was used both electronically and mechanically components, based on the techniques already developed for punched card machines. The Atanasoff Berry computer. Dr. John Atanasoff developed an electronic machine to solve certain mathematical equations. The ENIAC is from 1943 to 46. The electronic numerical integrator and calculator is ENIAC was the first all-electronic computer. The team developed ENIAC because of military needs. It was used for many years to solve ballistic-related problems.
Engineers labored to build another computational device, a machine which would directly influence the design of all future computers. America was a powerhouse producer of war implements, but by 1943 there was a critical shortage of a surprising component of the war machine: firing tables for artillery pieces. Firing tables allowed gunners to correctly aim their guns in different ranges, altitudes, temperatures, and wind conditions. Human computers frantically worked mechanical calculators to produce charts, but they had a hard time keeping up.
During World War II, there were a lot of guns coming off the assembly line. There were a lot of firing tables to be calculated. It was a really big job, and it was slowing down the delivery of guns to the front.
To solve the problem, John Mauchly, a physicist from the University of Pennsylvania, proposed building a giant electronic computer that could figure charts in minutes, not hours. The Army, desperate for a device to help them win the war, reluctantly committed to the proposed cost of $500,000. Mauchly and a brilliant graduate student in electrical engineering, Presper Eckert, set to work constructing ENIAC, the Electronic Numerical Integrator and Computer. Many times larger than Colossus, nothing close to ENIAC had ever been conceived. Nearly 100 feet long and weighing 30 tons, it contained almost 70,000 resistors, 10,000 capacitors, 6,000 switches, and 18,000 delicate vacuum tubes. Vacuum tubes burn out just like light bulbs. In a machine that contained 18,000 vacuum tubes, at least one had to be replaced every few minutes. After 2 years of intense work, the team completed ENIAC, 3 months after the Japanese surrender. Although it wasn't finished in time to help win the war, ENIAC was a marvelous machine. It could perform up to 5,000 additions, 357 multiplications, and 38 divisions every second.
The interesting thing about the ENIAC was that it had a general purpose capability. It could be reconfigured to solve other problems. And there was never any problem finding work for the ENIAC to do. All the armed services clamored for time on the machine. Industrial customers, university researchers wanted it. So it was kept busy right into the 1950s.
By far the most complex machine of its time, ENIAC still lacked many of the qualities of a modern computer. Its memory was very primitive and could only store a maximum of 20 10-digit decimal numbers. It had to be laboriously rewired each time it was programmed and couldn't make logical decisions based on its calculations. But ENIAC had proven that computers could be constructed. Just before the end of the Second World War, John von Neumann, an advisor to Eckert and Mauchly's ENIAC project, wrote a paper that was to greatly affect the next stage of computer design. Von Neumann possessed a photographic memory and was one of the principal scientists involved in the Manhattan Project. Von Neumann's paper delineated the structure of the modern computer. It was to have a processing unit, a controlling unit, memory, input, and output. But most importantly, in the evolution of computers, it would hold its programming internally in its memory. Internally held programs give computers their power and versatility, because an internal program can modify what it does based on data or the results of computations. Von Neumann's paper proposed a machine that truly had a general-purpose capability.
In this paper, he described the attributes of the computer, how it ought to be organized logically. That is, it needed to have a central processor where the calculations would be performed. It needed to have a memory where the program and data would be stored. It needed to have an output unit and an input unit of some sort. He laid out the logical plan, the map for a computer, and pointed the direction for the future.
The idea for storing programs internally was the last key to developing the true general-purpose computer. But whether it was von Neumann's idea has long been hotly debated. Eckert and Mauchly, who had worked with von Neumann, claimed they formulated internal programs as a natural part of their work building ENIAC, although they couldn't stop and incorporate the idea into the machine. However, Eckert and Mauchly weren't included as authors in the paper. They felt they had been betrayed. But realizing the computer might find itself useful in the business world, Eckert and Mauchly formed their own computer company. They set to work on a machine they called the Universal Automatic Computer.
The EDVAC from 1946 to 52. ENIAC programs were wired on boards that made it difficult to change the programs. The basic idea behind this concept is that a sequence of instructions and data can be stored in the memory of a computer for automatically directing the flow of operations. This feature considerably influenced the development of modern digital computers because of the ease with which different programs can be loaded and executed on the same computer. The EDSAC in 1947 to 1949, Electronic Delay Storage Automatic Calculator. The machine executed its first program in May 1949. In this machine, additional operations took 1500 microseconds and multiplication operation took 4000 microseconds. The UNIVAC 1, 1951. The Universal Automatic Computer, UNIVAC, was the first digital computer. Many UNIVAC machines were produced, the first of which was installed in the Census Bureau in 1951 and was used continuously for 10 years. In 1952, the International Business Machines IBM Corporation introduced the IBM 701 commercial computer. Let's now learn the various types of computer. A computer is one of the most brilliant inventions of mankind. With the help of computer technology, we were able to achieve storage and processing of huge amounts of data. The classifications of computers are operational based. Analog computers. Analog computer can perform several mathematical operations simultaneously. It uses continuous variable for mathematical operations and utilizes mechanical or electrical energy. Digital computers. They use digital circuits and are designed to operate on two states, namely bits 0 and 1. Digital computers are suitable for complex computation and have higher processing speeds. They are programmable. Hybrid computers. These computers are a combination of both digital and analog computers. In this type of computers, the digital segments perform processes controlled by conversion of analog signals to digital ones. Sizes and processing powers. Mainframe computers. Large organizations use mainframes for highly critical applications such as bulk data processing and ERP. Most of the mainframe computers have capacities to host multiple operating systems and operate as a number of virtual machines. They can substitute for several small servers. Microcomputers. A microcomputer with a microprocessor and its central processing unit is known as a microcomputer. They do not occupy space as much as mainframes do. A monitor, a keyboard and other similar input-output devices, computer memory in the form of RAM and a power supplying unit come packaged in a microcomputer. Personal computers are desktops. A desktop is intended to be used on a single location. Desktops are widely popular for daily use in the workplace and households. Laptop. Laptop runs on a single battery or an external adapter that charges the computer batteries. They are enabled with an inbuilt keyboard, touchpad acting as a mouse and a liquid crystal display. Their portability and capacity to operate on battery power. Supercomputers, the highly calculation-intensive task, can be effectively performed by means of supercomputers. Quantum physics, mechanics, weather forecasting, molecular theory are best studied by means of supercomputers. Tablet computers. Tablets are mobile computers that are very handy to use. They use the touch screen technology. Now we shall discuss the generations of computers. Generation in computer talk is a step in technology. It provides a framework for the growth of computer industry. Each generation along with its identifying characteristics are defined as first generation 1942 to 1955. We have discussed about some of the early computers: ENIAC, EDVAC, EDSAC, UNIVAC 1 and IBM 701. These machines and others of their time used thousands of vacuum tubes. Characteristic features of first generation computers are as follows. They were the fastest calculating device of their time. They were too bulky in size, requiring large rooms for installation. They used thousands of vacuum tubes that emitted large amount of heat and burnt out frequently. Hence, the room or the areas in which these computers were located had to be properly air conditioned. Each vacuum tube consumed about half a watt of power. Since the computer typically used more than 10,000 vacuum powers, power consumption of these computers was very high. As vacuum tubes used filaments, they had a limited life. Because the computer used thousands of vacuum tubes, these computers were prone to frequent hardware failures. Due to low mean time between failures, these computers required constant maintenance. In these computers, thousands of individual components were assembled manually by hand into electronic circuits. Hence, commercial production of these computers was difficult and costly. Since these computers were difficult to program and use, they had limited commercial use. Second generation, 1955 to 1964. John Bardeen, William Shockley and Walter Brattain invented a new electronic switching device called a transistor at Bell Laboratories in 1947. The characteristic features of second generation computers are as follows. They were more than 10 times faster than the first generation computers. They were smaller than the first generation computers and required smaller space. They consumed less power and dissipated less heat than the first generation computers. The rooms and the areas in which the second generation computers were located still required to be properly air conditioned. They were more reliable and less prone to hardware failures than the first generation computers. They had faster and larger primary and secondary storage as compared to first generation computers. They were easier to program and use than the first generation computers, hence they had wider commercial use. In these computers, thousands of individual transistors had to be assembled manually by hand into electronic circuits, making commercial production of these computers difficult and costly. Third generation is from 1964 to 1975. In 1958, Jack Clare Kilby and Robert Noyce invented the first integrated circuit. Integrated circuits, called ICs, are circuits consisting of several electronic components like transistors, resistors, and capacitors grown on a single chip of silicon, eliminating wired interconnection between computers. Characteristic features of third-generation computers are as follows. They were more powerful than second-generation computers. They were capable of performing about 1 million instructions per second. They were smaller than second-generation computers, requiring smaller space. They consumed less power and dissipated less heat than second-generation computers. The rooms or the areas in which third-generation computers were located were still required to be properly air-conditioned. They were more reliable and less prone to hardware failures than the second-generation computers, requiring lower maintenance cost. They had faster and larger primary and secondary storage as compared to second-generation computers. Time-sharing operating system also made online systems feasible, resulting in usage of these systems online applications. Unbundling of software from hardware gave users of these systems an opportunity to invest only in software of their need and value. Mini computers of third generation made computer affordable even by smaller companies. Fourth generation, 1975 to 1989. During fourth generation, semiconductor memories replaced magnetic core memories, resulting in large random access memories with very fast access time. Characteristic features of fourth generation computers are as follows. The PCs were smaller and cheaper than mainframes or mini computers of third generation. Although the fourth generation mainframes required proper air conditioning of the rooms and the areas in which they were located, no air conditioning was required for PCs. They consumed less power than third generation computers. They were more reliable and less prone to hardware failures than third generation computers, requiring negligible maintenance cost. They had faster and larger primary and secondary storage as compared to third generation computers. They were general purpose machines. Use of standard high-level programming languages allowed programs written for one computer to be easily ported to and executed on another computer. Graphical user interface GUI enabled new users to quickly learn how to use computers. PC-based applications made PCs a powerful tool for both office and home usage. Fifth generation is from 1989 to the present. VLSI technology came from ULSI ultra-large-scale integration technology in the fifth generation, resulting in the production of microprocessor chips having 10 million electronic components. Characteristic features of fifth generation computers are as follows. Portable PCs, called notebook computers, are much smaller and handy than PCs of fourth generation, allowing users to use computing facility even while traveling. Fifth generation desktop PCs and workstations are several times more powerful than PCs of fourth generation. Although fifth generation mainframes requires proper air conditioning of the rooms or the areas in which they are located, no air conditioning is normally required for notebook computers, desktop PCs and workstations. They consume less power than the predecessors do, and they are more reliable and less prone to hardware failures than the predecessors were, requiring negligible maintenance cost. The use of standard high-level programming language allows programs written for one computer to be easily ported to and executed on another computer. More user-friendly interfaces with multimedia features makes the system easier to learn and use by anyone, including children. Newer and more powerful applications, including multimedia application, make the system more useful in every occupation. Explosion in the size of the internet coupled with internet-based tools and applications have made these systems influence the life of even common people. Now in the end, let us summarize what we have learned in this lecture. The word computer comes from the word compute, which means to calculate. Computer generation like first generation, second generation, third generation, fourth generation, and fifth generation. Basic Pascal invented the first mechanical adding machine in 1642. Charles Babbage, a 19th century professor at Cambridge University, is considered the father of modern digital computers. Storage technology advanced very fast, making larger and larger main memory and disk storage available in newly introduced systems.